Hi, in this video, we're going to learn how to derive an exponential and log equation. So I'm going to divide into two columns here. And here I'm going to have all the exponential derivative. And on the other side, I'm going to have all log derivative. All right. Now, the derivative of a to the power of x will be the same number. So just a to the power of x. Okay. So if you need to derive a derivative of a to the power of fx, you would have a to the power of x, a to the power of x. So similar, a to the power of fx will be a to the power of fx. And then you're going to times that by the derivative of the top, which is f dash of x. And if you recall, we always do that after we finish every single derivative rule. And similarly, if I need to derive derivative log a of x, that will just give you 1 over x. Okay, so if you want to derive the derivative of log a of fx, that will give you 1 over fx, and then you're going to times that by f dash of x. So pretty much similar. Now we're going to go over a few examples of how to apply those formula. So let's start with example 1. Now let's say I have y equal a to the power of 4x minus 5 a to the power of x plus 6a to the power of x squared minus 2x, something like that. All right, now let's get started. So you can see there are three terms here. So what you do is just derive each term separately, and the coefficient you keep the same. Okay, so let's do the first term, the derivative of a to the power of x. So basically, this is a to the power of fx, a to the power of 4x here. So think about the formula that it will be a to the power of the same thing. So it will be just a to the power of 4x, okay? And then you're going to times by the derivative of 4x, which is 4. There you go. So you finish the deriving the first term. Now you just make it nicer. With the 4, you can put the 4 to the front as the coefficient. So you have 4a, 4x, right, like that. Then you're done. Now you do the second term. So the second term is minus 5. The 5 is a coefficient, and we bring it down. Okay. Now to derive a to the power of x, and then you can see a to the power of x is just right here. So the derivative of the most basic one is just the same. Okay, or you can think of something like this: a to the power of x will be a to the power of x, and when you times by the derivative of x, which is just 1, which is basically get back to the first formula. So either way, so a to the power of x will be just a to the power of x. So I just write here a to the power of x. Now the last term, 6 is a coefficient, keep the 6, and then I use the formula. So a to the power of fx. So a to the power of fx, right again. So times a to the power of x squared minus 2x, and then you times by f dash, which is the derivative of x squared minus 2x. The derivative of x squared is 2x, and derivative of minus 2x is negative 2. Okay. Now you can make it nicer. The 6 and 2x, you can times them together. So 6 times 2x is 12x. 6 times 2 is 12, like that. And then a to the power of x squared minus 2x, you can leave at the back. And then you're done. This is the derivative. All right. Now, what if I need to find, let's do the second example. So let's say this time I want to do something like a to the power of 3x minus 4 a to the power of x over a to the power of 5x, something like that. Okay, so to derive, you always have to expand and make them into individual terms like this. separated by the plus or the minus. So here you can see that the division here. So I can't derive them individually yet. I'm going to separate them out first. Okay, so I still have y here. So to separate them, I'm going to make them into two separate fractions, e3x over e5x, and then minus 4ex over e5x, like that. Then I'm going to simplify that, which is e3x over e5x. 3x minus 5x is negative 2x, minus 4. Ex minus 5x, x minus 5x is negative 4x. There you go. So you put them into individual terms, and then your next step is you are ready to derive. So you write dy over dx equal. Then you use a formula here. So a to the power fx, what do the formula say? That would be a fx times f dash. So I would have a to the power of negative 2x, and then times by the derivative of that, which is negative 2. So move that to the front, that's become negative 2a negative 2x. Okay. Minus 4 is a coefficient, just bring it down, and I use a formula to derive this. So a to the power of negative 4x, and then you times by the derivative of the top, which is negative 4. So negative 4 times negative 4 is positive 16, a negative 4x. There you go. And you can leave the answer like that. All right. So these are two examples of how to apply exponential rule. Now we're going to do more example of how to apply log rule. So let's do example 3. Now let's say now I want to do y equal 3 log a of 2x plus 5, something like that. And assuming that 2x plus 5 is positive, x will be bigger than negative 5 on 2. So that we always give you the condition that x have to be bigger than something to make sure that the thing inside is positive, right? All right, so the derivative of that, so dy over dx equal, so 3 we bring it down, okay? And log a of fx, we're going to use the formula here. So we set from the top, log a of fx. If we look at this one here, log a of fx is 1 over fx times f dash. So we do 1 over f of x is this, 2x plus 5. And we times by the derivative of 2x plus 5, which is 2. And then we just times them together. 3 times 2 equals 6. And then 6 over 2x plus 5. Okay, with x is bigger than negative 5 on 2. All right, we go. Let's see, here's another example. So let's say this time I want to do a square root of x. This is a bit harder. So let's say y equal log a of square root of x, something like that. All right, minus a something that's similar to this. So you can see so log a of fx will be 1 over, so we have dy over dx here. So 1 over fx, so 1 over root x minus a. And then you're going to time by the derivative of this. So think about how do I times, I'm just right here. So how do I find the derivative of this? So square root of x, you can make it x to the power of half, right? And derivative of 8 is technically 0, so you don't have to worry about 8. Now, to find the derivative of half of x, you apply the power formula. So half, you bring it down, and then x, and you take 1 on the top. So a half minus 1 is negative a half. So this is the derivative of f of x. So I'm going to times by this, times by a half, x to the power of negative a half. Okay. Then if I make it nicer, I would have 1 over root x minus a times by a half, and then x to the power of negative half, you can make it to the bottom become x to the power of half, which you can turn that into square root of x like that. So eventually, when you time them together, you would have 1 times 1 equal 1. And then here you have 2 root x times by this, times by root x minus 8.